The next tool that was kind of built magically behind the scenes that sits on top of JPA is an enterprise Java Bean. Now, enterprise Java Beans have gone through a lot of permutations through the years. Really, JPA was built because of a somewhat undesirable early implementation of enterprise Java Beans. But the idea behind an enterprise Java Bean is to take us away from the easy writing code that we've written so far and get us into a little bit more ruggedized piece of code. So everything we've done at this point is we grab data, we update the database, we don't do anything more than happy paths. We don't deal with security issues, we don't deal with exception handling, we don't deal with any behavior past create, read, update, and delete. So how would we centralize? How would we make those data common and behavior? So in the real world, we have to think of a lot of things. What is the relationship between data? What if I delete one thing and the other thing's not out there? What about error handling? What if the database is down? What do I do in response to that? Transactions. So we just noticed in the Hibernate code, we create a transaction, which basically allows us to commit or roll back a bunch of database all at the same time. If you've done database stuff, you probably understand what a transaction is. But the idea is I don't want to take money out of your account and fail putting it into my account, but never put the money back into your account. That's what a transaction is all about. Make sure everything happens at once. I don't get the money in my account until it's removed from your account, and you don't get the money taken out of your account until it's added to my account. It all happens at once. The question of security, who's allowed to use these things, what are they allowed to use, scalability, how do I go from one computer to 10 computers? If I want to grow a website, I can't just live on one machine and make one really big fat machine it's got 50 processors in it. I want to be able to have multiple servers. I want to be scalable. And then the question of connectivity. How do I connect these things together? How do I connect them to mainframe applications? How do I connect them to web services and all that stuff along the back end? And so these are all common problems. Most apps have to deal with this. Stores need to ensure their orders are properly created. Banks want, transactions we just talked about to go well when I deposit and withdraw money. If I'm a fantasy sports owner, I don't want to lose a guy from my team until I have the new person back on the team. It's just the way we need transactions to happen. We need to be able to solve these problems across it of security and transactions and error handling and such. So if we have common problems, we can create components that give us common solutions. We have our nurses that deal with medical things, our fire that deal with fire things. They're the same whether they're on a military base or in a neighborhood. They do functionally the same thing. So the most common stuff I'm going to be able to do is look for errors, handling the transactions, checking user permissions. And so to do that, I need a framework. So I build common components to solve business problems. I also want to build common components to build plumbing, to build the pieces in the back end that I want to solve in common ways, because those are expensive. I don't get paid to do security. I don't get paid to handle errors, but I need to do them in order to continue to get paid, because if I have an insecure app that doesn't handle errors right, nobody's going to want to use it. So that's the concept that leads us to the enterprise Java Bean. What if I can allow you as a developer to focus on the core business functionality? What if I can give you a place where your security is taken care of, where your scalability is taken care of? Think of the EJB as kind of the little pop-up offices that are popular now. You can go and set up a one-room office, and somebody else will pay for the lights and make sure the coffee machine's filled and give you an admin you can rent, or give you a conference room you can rent. And you can grow accordingly. You can go from one office to two offices. You can go 2 offices to 5 offices. But all the infrastructure is provided for you. You don't have to figure it out to start with. Maybe someday you'll figure it out yourself, but for now, this is the way you want to start with. And that's what an enterprise Java Bean is. It's a little app in a box. You write the logic that helps there. We're going to help you deploy it. We're going to help you manage the connections. We're going to manage all that stuff for you. An EJB becomes a little program of its own. It has its own interface. It has services it does for clients. It tracks its own data. And there's ways it can be deployed to be scalable, to be able to grow accordingly and be able to jump up and go from one instance to many instances that are out there. So there's a bunch of types of EJBs that are out there. And not all of them exist anymore. There used to be this concept of an entity EJB. It stored data and logic all in one. It was this little application that was not only a single instance of the reusable code, it was actually an object that was a single instance out there. When you wanted to go and find out about a product, there was one product object that lived on one server, and everybody went and go and asked for that. Turned out that was kind of a bad idea. It wasn't very scalable. It was kind of slow. And so the entity became the JPA bean out there. And so what we got left with was this idea of a session bean. It's services that work with these objects that are entities, that get passed around back and forth. And the services have create, read, update, and delete that it uses from behind the scenes of the entity. And so the other type of service out there, which is a real-time request back and forth sort of thing, like a telephone call, is the message-driven entity beans, which allows asynchronous services. So think of it this way. You make a phone call to me, we're talking real time. You send me an email, I respond to that in my own time, I get back to you in the own time. You're not sitting there waiting for me to respond to you immediately. I'm not sitting there waiting for you to call me immediately. I might have other things I'm working on, and it allows us to do that asynchronously. And then I can do that behavior very easily using a message-driven bean to be able to do queuing and a bunch of stuff, just like I can do real-time calls. So JPA came out as a brainchild of how to make EJBs better. They were big solutions, but not everybody needs all of that to be able to simply get the really cool stuff of not having to write the SQL. And so Hibernate was created as a response to EJB, and then Java pulled it back in as JPA and said, oh, well, this is a good idea. Let's create this thing, and then we'll get rid of this big heavyweight component. I don't need the circus train to drive to work every day. Let me just give you a car, which you can use on your own, but we can also use it with the train. You can drive the car right back up in here, and we can use it inside of there. So EJBs are really great for this common programming model. I know how they're built. I know how common problems are solved. I know how they're deployed. I know how I can manage them. I can scale them. I can deal with stuff in my server. They're really great for my app team to deploy. I know how to integrate between them. But they require this full-blown application server, which can be expensive. They require me to deal within their programming model. That old programming model used to be heavyweight and expensive and difficult, which is why the new stuff came up. We can do it much easier and lighter and cheaper and be able to build it just on Tomcat, where it used to be that build with the EJBs, I had to pay expensive for WebLogic or WebSphere or one of those big servers. So that's not as big of a deal anymore, but that reputation of where they started still lies over the top of them. There's alternatives that are more flexible. Perhaps they're certainly lighter weight. They don't require the server at all to do most of these features, but there are advantages of EJBs, and they might come across at some point in our application. We talk about them because the whole middle of our application that we looked at last time was built within EJBs. And so you can look at that logical piece that I built within the EJB package wraps around the JPA part and does the create, read, update, and delete. It offers those things up as internal services to our website, but could also be deployed as web services, which you can see from the web services demo.